All right, calculus, welcome back to another video here, lesson 4, I believe, for whenever you have a remote learning day. So this is back on page 5 of that review packet, exercises 0.1. Fine, again, I'm mostly abbreviating the directions here, but you can see the directions on your page. Find the distance between the points, the slope of the line through the points, an equation of the line through the points as well. Okay, so the first thing we're going to do is we're going to find the distance between 1, -2, and -1, -3. Again, I taught you in Honors Algebra 2. Find distance this way. Again, there's that formula. It's like the square root of x1 minus x2 squared plus the square root of y1 minus y2 squared. But the distance formula is just Pythagorean theorem. The distance squared is equal to the x distance that you travel squared plus the y distance that you travel squared. Then you don't have to worry about any negatives. If you went from 1 to -1, you traveled 2 in the x direction. That is the x distance squared. Plus, if you went from -2 to -3, you traveled 1 in the y direction. So distance squared is 2 squared plus 1 squared. Distance squared is 5. That means little lowercase d there. Lowercase d is square root of 5 for distance. Again, yes, slope is y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. I don't know if I said the same thing twice. It's difference of y's over difference of x's. Now, I like to do the bigger y minus the smaller y. So -2 minus a -3. But because I chose that to be my first y, 1 has to be my first x. So it has to be 1 minus a -1, ... you get 1/2. That's slope. So, using the tripod here, going okay. Slope aligned for us right now is y equals mx plus b. That is slope-intercept form. When we talk about derivatives, equation of the tangent line, we will use point slope form. So y equals mx plus b means y equals 1/2 plus b, 1/2 x plus b. I'm going to take an x and a y. I think I used 1 comma -2, that first one. Plug -2 in for y, 1 in for x, subtract 1/2 from both sides. B is a -5 over 2. That is the equation of the line. That's a good question. I really like that. Hint, hint, wink, wink for any quiz or exam. That's a good one. All right, so in 22, I kind of changed the directions. I just want you to find an equation of the line with that slope that goes through that point. Okay, so again, we're on page 5, exercise point 1. The slope is -1/2. The point it goes through is -2, 1. Y equals -1/4 x plus b. Plug -2 in for x, 1 for y, subtract 1/2 from both sides. You get y is a -1/4 x plus 1/2. Then, are the two lines parallel, perpendicular, or neither? There's the first line, slope of -2. There's a second line, slope of 1/2. Yes, you can distribute. You're still going to get y equals 1/2 x, I think, plus 2 here. For here, you're going to get y equals -2x minus 3. The slopes are going to remain the same. -2 and 1/2, they're not the same thing, so they're not parallel, but the slopes are opposite reciprocal. -2, if you give it the opposite sign, it's 2, and if you flip it, you get 1/2. That means they're perpendicular, opposite reciprocal slopes. 28, you got to do a little bit of work for both. I'm going to subtract x, divide by 2. There's a question like this in the ACT that I am putting up on the interwebs. So slope's -1/2. On this next one, sorry, still working with this. Subtract 2x from both sides, divide by 4. Slope is -1/2. Slopes are the same. The lines are parallel. So in neither would be they're not the same and they're not opposite reciprocals. Like -3 to -1/3. They're reciprocals but not opposite. All right. Still here, finishing up page 5. Finishing up page 5 with number 29. Find an equation that is of the line, or find two equations that so find an equation that is parallel and perpendicular to that line. at that point. So the first thing, again, I don't need to distribute. I don't need to know that this is y equals 2x. All right, all I need to know is the slope is 2. This line has a slope of 2. So its parallel line, or line parallel to it, is going to have a slope of 2. Just going to go through a different point. All right, can't go through 2, 1, or it'll be the same line. So, I'm sorry, it is going to go through 2, 1. All right, it is going to go through 2, 1. Now, this one, if you plug 2 in, this does not go into 2, 1. So your line is going to go through 2, 1. That one doesn't. Anyway, y equals 2x plus b has the same slope. Plug 1 in for y, 2 in for x. Your y-intercept's negative 2. So y equals 2x minus 3. That is y equals 2x. So they're close, but they're not the same line. Now, the perpendicular line will have an opposite reciprocal slope. So if this guy has a slope of 2, flip it, give it the opposite sign. Y equals negative 1/2 x plus b. Plug 1 in for y, 2 in for x. Do that algebra. Y equals negative 1/2 x plus 2. Your perpendicular line. Okay, now we are on exercise point 1, page 6. Find the domain of each. Well, first off, a cubic function. You can take the cubed root of a negative number, or a positive number. Okay, the cubed root of negative 8 is negative 2. Square root of negative 8, that's imaginary. So there is nothing that you can't plug in for x. Some folks might be like, well, if you plug 1 in, you get 0. Yeah, the cubed root is 0, 0. The domain is all real numbers. So instead of writing that interesting r, we're going to write negative infinity to infinity. That means all real numbers. Now let's talk about 45. 45 is interesting. First off, x cannot be 5. That's a vertical asymptote. So we know x can't be 5. Then we also know you can't take a square root of a negative. So I'm going to take what's inside that square root and set it equal to 0. X squared minus x minus 6. I'm going to set it equal to 0. I'm going to factor what multiplies 6 differs by 1. Negative 3, positive 2. Set it equal to 0. So I know when x is negative 2 and when x is 3, I get 0. So again, like before, I recommend as we're learning this to set up. I'm running out of real estate here. Again, this is a learning curve for all of us. From negative infinity, I'm just looking at the square root here. From negative infinity to negative 2, something's happening inside the square root. From negative 2 to 3, something is happening. And from 3 to infinity, something's happening. That's my interval. Here's my test number. I'm going to plug negative 3. Negative 3 fits in there. 0 fits in that interval, and 4 fits in that interval. You know that you are allowed to take the square root of 0 or a positive number. So when I plug negative 3 in there, I get 9 plus 3 minus 6, which is 6, a positive number. That's a-okay. If I plug 0 into the square root, I get the square root of negative 6, which is no bueno. Imaginary number. When I plug 4 in, I get, I think, 6 again. Positive number. So negative infinity to negative 2, valid. 3 to infinity, valid. From negative 2 to 0, not good. So the domain is shaping up here now. So I know x can be anything from negative infinity, negative 2, and 3 of them or above, but it can't be 5. 5's no good. So here's how I write it. Now remember, this is going to look odd. Okay, this is definitely a challenging one. From negative infinity to negative 2, everything is good. Why do I use a bracket here? Because x is allowed to be negative 2. You're allowed to take the square root of 0. It is 0. Union from 3, not to 3 to infinity, but 3 to 5. Bracket around 3 because, again, you're allowed to have the square root of 0. If you plug 3 in here, you get the square root of 0, which is good. Not a bracket with around 5, a parenthesis, because x is not allowed to be 5 down over here. That's a vertical asymptote. Union 5 to infinity. This right here is basically saying anything from 3 to infinity is good, but not 5. Except for that one number. And that's how we're going to write things. I know it looks long-winded, but that is how we're going to write things. All right, not bad. Let's see if we can try this next page. What is the domain of this? Well, first off, the only thing I got to worry about is dividing by 0. Chapter 8 in Honors Algebra 2. So I set what is in the denominator equal to 0. I get plus or minus 1. X is not allowed to be -1 or +1. So before, you might have wrote it in set notation, where we had the set, the domain is any x such that x does not equal -1 or +1. In calculus, though, there you go. Calculus, we're going to write it using interval notation. X can be anything from -infinity to -1, not including -1. Union from -1 to 1, not including both. Y, you can't divide it by 0. Union, 1 to infinity. A lot of plus or minus 1s are written there. 50 is pretty easy. Given f of x is 3 over x, find f of 1, f of 10, f of 100, and f of a third. So, sorry, just plug all those numbers in for x. Plug in 1, you get 3. Plug in 10, you get 3 over 10. Plug in 100, you get 3 over 100. Plug in a third, and you get 9. That's fun. All right, so that is the end of page 6 with exercises 0.1. And that's a great place to stop for now. This is Yak Math Videos signing out.